Many towns and cities need better internet. The work to build it is called Fiber to the Home, or FTTH. This work is very important. It connects families, schools, and businesses to the digital world. But this work is also very hard. It involves many slow, difficult steps. Crews must dig long trenches in the ground. They must carefully place delicate fiber optic cables inside protective tubes. They must join these tiny glass threads together with perfect precision. This process is slow. It costs a great deal of money. Mistakes cause frustrating delays and expensive rework. Sometimes the work can even be unsafe. The promise of a better way is here. That promise comes from artificial intelligence, or AI. Think of AI as very smart software. It learns from information and experience and spots problems humans might miss. It analyzes complex schedules and finds efficiencies. It can guide a worker to perform a task perfectly. With AI, FTTH builds go faster, become safer, and deliver higher quality with fewer problems later on. The first major pain in any large construction project is scheduling. A fiber build involves coordinating many teams and expensive trucks and machines. A simple mistake can create a chain reaction of delays. A crew might arrive, but the trencher is not there. Materials delivered to the wrong spot force hours of waiting. This wasted time is costly. It pushes back deadlines and frustrates managers and homeowners waiting for service. AI offers a powerful promise to solve this puzzle. Imagine a planner with perfect memory of every past project. It remembers tasks that take longer and difficult routes. It learns which crew and equipment combinations work best. Then it creates realistic, efficient schedules that work in the real world. Fewer wasted days, less waiting around. An AI might flag a neighborhood with deep roots. Based on past data, digging takes 30% longer. It adds time and recommends better equipment. This prevents inevitable delays. A small adjustment can save a whole day and save thousands in labor and equipment. AI right-sizes trucks and tools for the day's tasks. Across a city, it cuts fuel, maintenance, and rentals. Crews have the right tools and time to do it right. Operations become smoother and more predictable. AI turns scheduling from a headache into a strategic advantage. That is pain to promise to proof, on the calendar and on site. A second major pain point is ensuring quality. Small mistakes can become big problems later. Too shallow trenches leave conduit vulnerable. A poorly sealed splice box can let in water, ruining delicate connections inside. Fixing it later is extremely expensive. AI can act as a tireless inspector everywhere at once. Using computer vision, it understands images like a human. Use drones or phones to capture the work. The AI analyzes images in real time. It measures trench depth from a photo and flags sharp bends that could cause damage. It confirms seals on splice boxes. You get immediate feedback before mistakes become costly, with precise location to fix now. A quick on-the-spot repair takes minutes instead of weeks later with a new crew and machine. It even verifies final cleanup. Quality standards become consistent across every site. Higher quality networks mean fewer repair calls and happier customers. Turn expensive rework into simple fixes. It is a simple but revolutionary change in quality control. From pain to promise to proof. Caught early, fixed fast. Next, perfecting the splice with AI-assisted testing. Splicing is one of the most delicate and critical tasks in building a fiber network. It involves perfectly aligning and fusing two glass fibers thinner than a human hair. Then testing ensures minimal light loss. That test uses an optical time domain reflectometer, an OTDR. It sends a pulse of light and produces a trace graph. Reading traces takes skill and time. Inexperience can approve bad splices or fail good ones, slowing progress and hurting performance. Errors ripple into day 2 problems. AI learns from thousands of traces to recognize patterns. Good splice, dirty connectors, sharp bends, and cracked fibers. Tests get instant AI analysis. Technicians see clear pass, fail messages, and action recommendations. AI analyzes in under a second, much faster than manual review. On 144 fibers, testing time can be cut in half. It pinpoints faults so crews fix the right spot. Faster testing accelerates the build schedule. More accurate tests catch issues before go live. Day 2 problems and costs plummet. Start robust and reliable from day 1, improving experience and reducing future maintenance. That is the Splice perfected with AI. Many tasks in fiber installation require extreme precision. Drilling a hole in the right spot matters. Wrong placement can hit a water pipe or an electrical wire, costly and unsafe. Cable routing must avoid tight bends. Small mistakes cause second or third visits, frustrating customers and adding cost. AR can be an expert guide over every technician's shoulder, using phone, tablet, or glasses to overlay instructions. It shows the precise, safe spot to drill or mount. It draws the correct cable path through complex cabinets. Clear, unambiguous, right where the work happens. Errors drop, training speeds up. A new technician may be unsure where to place the ONT. AR projects the exact location using design plans. No guessing, just follow the guide. Weeks of classroom can shift to on-the-job AR coaching, from connecting the drop to configuring the router. Senior time refocuses on higher value tasks. Techs gain confidence and deliver quality from day 1. AR turns uncertainty into precision, reducing errors and accelerating learning. Real help, right in the field. A large FTTH project is like a moving factory with hundreds of sites. Each needs specific materials daily: fiber, conduit, connectors, splice sleeves. Managing this supply chain is painful. Run out of a critical part and work stops. Order too much and capital is wasted. And parts can be lost or damaged. AI brings intelligence and predictability. It reads schedules and past usage to forecast demand. It predicts needs per crew and date. Shift from reactive to predictive deliveries. Pick lists auto-generate. Routes optimize across sites. Materials arrive just in time. Work continues without interruption. No frantic calls for rush deliveries. Overstocking and waste are prevented. It coordinates across multiple depots. Instead of a rush order, it schedules an internal transfer. Costs drop and waste shrinks. The flow of work is never broken by a missing part. AI brings calm and order to materials management, from chaos to choreography. Next, small proofs that add up to big impact. You do not need a massive system to see benefits. Small, measurable improvements add up. This is not about replacing teams with robots. Use simple tools already available: smartphones, drones, and a layer of smart software. The data you collect fuels the AI engine. Avoid 1 day of delay per month and savings become substantial. A day lost for a 5-person crew and rentals costs thousands. Multiply across 20 crews for a year, hundreds of thousands. Catch 1 trench depth error per week and avoid a redig. Early fixes cost a fraction of late fixes. The proof-gathering tools are in your pocket. Finding issues on-site saves time and fuel and improves job satisfaction. AR prevents costly and dangerous mistakes. Small wins build confidence in the tech. Save 2 hours on a job and teams become advocates. Change happens through proven wins. Start small, measure, share the proof. Adopting new tech can feel overwhelming. Do not try to do everything at once. Start with a focused pilot. Choose one specific problem to solve. Pick one AI tool to help solve it. Keep the rest of your process the same. See if AI reliably flags issues like depth and sharp bends. Train only the pilot crew and their supervisor. Define KPIs, issues found and time to fix. Compare against similar sites without the tool. Clear, data-backed results are powerful. Use the proof to make your decision. If results are good, expand to a few more crews, or launch a second pilot, like AI splice testing. Methodical steps ensure success. Pick one site, Choose one problem. Test one AI tool. Start with computer vision for quality checks or an AI scheduler for a small set of crews. Train a few people, collect data, and measure time saved. Count errors prevented and rework reduced. Start small, prove value, build the case. That is the surest path to success. The challenge of bringing faster internet to every home is significant, but it is a challenge we can meet. Traditional methods are slow, with delays, high costs, and safety risks. AI is not distant. It is practical and available today. It creates smarter schedules, provides eyes for constant quality, adds expertise to perfect delicate connections, guides technicians to avoid errors, and manages a complex supply chain with foresight. It is a partner that empowers our skilled workforce. Planners see problems before they happen. Technicians make the right decision at the right moment. Managers ensure quality and safety across the board. Integrating AI reduces rework and delays, so projects finish in a fraction of the time, bringing high-speed fiber to more people, faster. The result is a stronger, more reliable network, benefiting companies, crews, and communities. The journey begins with a single, deliberate step. Do not wait for a perfect solution. Pick one site, choose one problem, and test one AI tool. Start with computer vision or a small AI scheduler pilot. Train a few people and measure the time you save. Count errors prevented and rework reduced. Let results speak for themselves. Pilot to rollout. Technology and human skill working together. We build the infrastructure society needs. Faster, safer, better. The tools are here. The path is clear. Embrace collaboration to accelerate fiber to every home.